Welcome to 7.4. Today we're going to be talking about solving logarithmic equations and inequalities. The two vocab terms we have for this section, we've got a logarithmic equation, that's an equation that contains one or more logarithms, and we have a logarithmic inequality, an inequality that contains one or more logarithms. To start out, we're going to be solving a logarithmic equation. So we've got the log base 36 of x is equal to 3 halves. What we're going to do is we're going to bring back what we did in the last section, and we're going to rewrite this as an exponent. So if I take the log base 36 of x equals 3 halves and I rewrite it as an exponent, it should look something like this. 36 to the 3 halves equals x. Now to make this a little easier, because we don't necessarily like fractions in our exponents, I can rewrite 36 as 6 squared. So now I've got 6 squared to the 3 halves. Multiplying my exponents here, I get 6 to the third is equal to x. If I type in 6 to the third in my calculator, I get that x is 216. For our next example, we've got the log base 9 of x is equal to 3 halves. Once again, rewriting this as an exponent, I should get 9 to the 3 halves is equal to x. Again, working with fractions as exponents isn't the best way, so if I can rewrite 9 as 3 squared, that should help me out. So I've got 3 squared to the 3 halves is equal to x. Again, multiply my exponents together. 2 times 3 halves gives me a 3. So my answer would be 3 to the third power, which if I type that into my calculator, I should get my answer is x equals 27. Our next example, we've got the log base 16 of x is equal to 5 halves. And again, first thing I want to do is I want to rewrite this as an exponent, so 16 to the 5 halves is equal to x. I don't want the fraction as an exponent, so I'm going to rewrite 16 as far down as I can, which happens to be 2 to the 4th power. So I've got 2 to the 4th to the 5 halves. Multiplying my exponents, I get 2 to the 10th is equal to x, and if I type that into my calculator, I should get an answer of x equals 1024. Go ahead and pause the video, solve this one on your own, and then hit play and see how you did. You should have rewritten it as 3 to the 4th equals x, giving you an answer of x equals 81. The next thing we're going to talk about is the property of equality for logarithmic functions. If a is a positive number other than 1, then the log base a of x is equal to the log base a of y if x is equal to y. Okay, so the base of our log has to be the same, and if it is, then we can set what we're taking the log of and set it equal to each other. Okay, so we're going to use that in the following examples. So now we're asked to solve the log base 2 of x squared minus 4 is equal to the log base 2 of 3x. Again, notice how the base of our logs are the same, or they're both a 2. So what I can do is I can take what we're taking the log of in each one and set them equal to each other. So I can say x squared minus 4 is equal to 3x. Now we're going to solve this, and if you remember from back when we did quadratics, when we have a quadratic equation, we have to have it equal to 0. So I'm going to subtract the 3x over to the other side, giving me x squared minus 3x minus 4. From here, there's a handful of different ways we can solve it. We can graph it on our calculator and find the zeros. We can factor it. We can use the quadratic formula. Okay, we have all of those options available to us. If we want to use the quadratic formula, remember that is negative b plus or minus the square root of b squared minus 4ac all over 2a. And that comes from ax squared plus bx plus c. So for here, we use this. A is 1, b is a negative 3, c is a negative 4. So negative b would be a positive 3, plus or minus negative 3 squared minus 4 times 1 times negative 4, all over 2 times 1. Cleaning up under the square root, negative 3 squared is 9, minus 4 times 1 times negative 4 gives me a negative 16. 2 times 1 is 2. Minusing a negative is just like adding a positive, so underneath my square root, I've got 9 plus 16, which is 25. Square root of 25 is 5. So my two answers is going to be 3 plus 5 over 2, which is 8 over 2, which gives me 4. And then 3 minus 5 over 2, which is negative 2 over 2, which is a negative 1. So my two answers are 4 and negative 1. For our next example, we're solving the log base 3 of x squared minus 15 is equal to the log base 3 of 2x. Okay, once again, bases are the same. So I can take what's inside the log and set them equal to each other. So x squared minus 15 equals 2x. Subtract the 2x over to the other side. X squared minus 2x minus 15 equals 0. Now we're going to do it by factoring. So if you remember factoring, you start with first times third. So x squared times a negative 15. I get negative 15x squared. I take that product and I break it up into two numbers that multiply together to get negative 15 and add up to this negative 2 here in the middle. And that turns out to be negative 5 and positive 3. I replace the negative 2x with those two that I just found, so x squared minus 5x plus 3x minus 15. And then last, I factor by grouping. So I put the first two in a group, the second two in a group, and I factor out what I can. I can take an x out of the first one, I can take a 3 out of the second one. So my two factors are what's inside the first and what's outside. So inside of both, and then the other one's outside of both. So if I have x minus 5 times x plus 3, once I have them factored, to solve, I set each one equal to 0 and I solve. So x minus 5 equals 0, I can add 5 to both sides. X plus 3 equals 0, I subtract 3 from both sides, giving me my two answers of 5 and negative 3. Our next example, we got the log base 6 of x squared minus 6x is equal to the log base 6 of negative 8. Again, bases are the same, so I can take these two terms and set them equal to each other. So x squared minus 6x is equal to a negative 8. Got to have a 0 on one side, so I'm going to add 8 to both sides, giving me x squared minus 6x plus 8 equals 0. We'll go back to the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 1, b is a negative 6, and c is a positive 8. So negative b would be a positive 6. Underneath the square root, negative 6 squared minus 4 times 1 times 8 all over 2 times 1. Cleaning up under the square root, negative 6 squared is 36. 4 times 1 times 8 is 32. On the bottom, 2 times 1 is 2. 36 minus 32 gives me a 4. So I've got 6 plus or minus 2 over 2. So my two answers are going to be when x is equal to 6 plus 2 over 2, which gives me 8 over 2, which is 4. And x equals 6 minus 2 over 2, which gives me 4 over 2, which gives me 2. So my two answers are x equals 4 and x equals 2. Go ahead and pause the video, solve this one on your own, and then hit play and see how you did. Regardless of how you did it, you should have gotten an answer of x equals 4 and x equals negative 2. Next, we're going to look at the property of inequalities for logarithmic functions. So if b is greater than 1 and x is greater than 0, and the log base b of x is greater than y, then x is greater than b raised to the y. If b is greater than 1 and x is greater than 0, and the log base b of x is less than y, then we would say 0 is less than x, which is less than b to the y. So we're still rewriting it as an exponent, but instead of an equal sign now, we're going to carry over the inequality. The only thing you'll have to keep an eye on is this part here. When it's less than, we got to have this 0 is less than part of it as well. And then we can go and solve from there. So if I have the log base 3 of x is greater than 4, and I rewrite that using the property that we have, okay, I'm going to say that x is greater than 3 to the 4th power, which if I typed 3 to the 4th into my calculator, I would get 81. So my answer would be x is greater than 81. Our next example, we've got the log base 4 of x is greater than 3. Again, since it's greater than 3, or greater than, I use x is greater than and then b to the x, or to the y. So I've got 4 to the third power, which if I type that in, I get 64. So I should get x is greater than 64. Now we have the log base 2 of x is less than 4. Since we have less than, I need to have 0 is less than x, which is less than b raised to the y. So now I've got this 0 less than x less than, if I type in 2 to the 4th power into my calculator, I get 16. So my final answer would be 0 is less than x, which is less than 16. So again, when you've got this minus, you have to remember that 0 is less than part of your answer. Go ahead and pause the video, do this last one on your own, and then hit play and see how you did. Because it's less than, you should have set 0 is less than x, which is less than 4 to the third power. 4 to the third power is 64, so your final answer should be 0 is less than x, which is less than 64. So the other property of inequality for logarithmic functions, if we got a b value greater than 1, then the log base b of x is greater than the log base b of y, if and only if x is greater than y. Same thing can be said with less than, if the log base b of x is less than the log base b of y, if and only if x is less than y. So if we have the same base in both sides, we can take what we're taking the log of and have that be the inequality and solve for our variable. So if the log base 6 of x is greater than the log base 6 of 35, then I can say that x is greater than 35. If it was the other way around, if the log base 6 of x is less than the log base 6 of 35, then I can say that x is less than 35. So if we have the log base 4 of x plus 3 is greater than the log base 4 of 2x plus 1, again, we've got the same base for both. So I can take what the log is of on the left and set it greater than what the log of is on the right. So x plus 3 is greater than 2x plus 1. Now I can solve for x. Subtracting an x over to the other side. Subtract the 1 over to the other side. Divide both sides by 1. And then the last thing I would do here is I would rewrite it so that the variable is on the left. So instead of saying 2 is greater than x, I would say x is less than 2. That would be my final answer. Our next example, we got the log base 5 of 2x plus 1 is less than the log base 5 of x plus 4. So again, since our bases are the same, I can take what they're taking the log of each one and use that in my inequality. So I should have that 2x plus 1 is less than x plus 4. Subtract an x from both sides. Subtract the 1. Divide both sides by 1. I should get an answer of x is less than 3. Our next example, the log base 4 of 2x plus 5 is less than the log base 4 of 4x minus 3. Again, since the bases are the same, I just use what's inside the parentheses, so 2x plus 5 is less than 4x minus 3. Now I solve for x. I can subtract 2x from both sides, add 3 to both sides, divide both sides by 2. So I've got 4 is less than x, and again, we want the variable on the left side, so instead of saying 4 is less than x, I would say that x is greater than 4 as my final answer. Go ahead and pause the video, solve this last one on your own, and then hit play and see how you did. You should have started out with 2x is greater than 6x minus 8. Subtract 2x from both sides, you get 0 is greater than 4x minus 8. Add 8 to both sides, you get 8 is greater than 4x. Divide both sides by 4, you get 2 is greater than x. Rewrite that with the variable on the left, we should get that x is less than 2 as our final answer.